Hello viewers. So in the last class we have discussed about Johnson-Trotter algorithm. Now today we'll be looking into the example for it. For the Johnson-Trotter algorithm, I have taken the input size as n is equals to 3, where the integers are 1, 2, 3. I have taken as per the input size given. So since n is equals to 3, I have taken 3 integers. So this is what the initial step is. Initial step that we have discussed, which is initialization 1 to n in ascending order. So n is equals to 3. So 1, 2, 3 arranged in ascending order. Now the second step is that I have to identify the mobile elements. So what is mobile element? I am repeating once again. The element which is greater than the adjacent element is considered as the mobile element. Now let us start identifying the mobile elements for each permutation. So given 1, 2, 3. So and the directions are on to the left side. Every time the direction will be given like this. For this 1, 2, 3 will generate what k is. K is nothing but mobile element. So you have to check each and every adjacent element in its direction. So for the one, the arrow pointing to the left direction. So in that direction you have to look for any element that is less than this adjacent element. So the one which is whose direction is pointing to the left, there is no element present here, so we can move on to the next element. Now compare this element to its direction pointing towards 1. So the direction is pointing towards 1. Now compare these two elements. So 1 is less than 2. So it means that this adjacent element is greater than 1. Therefore I can write k is equals to 2 as one mobile element. Now moving on to the next element 3. Again look into its direction. So the arrow is pointing towards 2. You have to compare 2 and 3. So now 2 is greater than 3. Sorry, 2 is less than 3. So it means that 2 is less than 3, therefore 3 is greater. Hence I can identify this 3 as the mobile element as well. So k is equals to 2 comma 3. So what you have to do, start checking or comparing the elements in the direction given. So first for the first element 1, in the pointing direction there is no element present. Therefore I am moving on to the next element. So for this element 2, there is a pointing direction towards 1. So 1 is less than 2. Therefore, I have to compare 1 and 2. 2 is greater, hence the mobile element k is equals to 2. Now move on to the next element, compare those two elements in the pointing direction. So for the 3, pointing direction is towards 2, therefore I have to compare 2 and 3. So 3 is obviously greater than 2, therefore there is one more largest mobile element which is 3. So far k is equals to 2 comma 3. So these are the two steps we have done. First step is initial permutation, arrange the elements in the ascending order. Next step is based on the arrows pointing towards the direction, compare the elements and identify the mobile elements. So far I got mobile elements as 2 comma 3. Now according to the algorithm we have discussed, once the mobile elements are identified, you have to find out the largest mobile elements. So amongst the mobile elements I got, I have to pick the largest mobile element. So now in our example, k is equals to 2 comma 3, the largest mobile element is 3, therefore k is equals to 3. So that implies k is equals to 3 is the largest mobile element. Now what I have to do after the identifying the largest mobile element, the next step is that swap element k with the adjacent element to which arrow points. So the largest element is k. So k is equals to 3. Now I have to swap this kth element, that is k is equals to 3, to the pointing direction of the element. So I have to swap 2 and 3. So that is what given in algorithm, swap element k with the adjacent element to which arrow points. So for the element k, the adjacent element is 2, I have to swap these two. Now the new permutation will be 1, I have swapped 3, swapped 2. So now for this new permutation, again I have to start with the same steps. I have to identify the mobile element again now. So consider, now compare 1. So in the pointing direction of 1 there is no element present, therefore I can skip to the next element which is 3. In the pointing direction of 3 there is element called nothing but 1. So 1 is smaller than 3. So obviously I can write k is equals to 3. Now moving on to the next direction. So you have to check each and every element, then only you can finalize the mobile element. So moving on to the third element, that is 2. In the pointing direction of 2, so 3 is there which is greater than 2. Therefore 2 cannot be a mobile element. So far for this new permutation, I got the mobile element as k is equals to 3. So now what is the next step I have to do? I have to swap the mobile element with its adjacent element in its pointing direction. So for the k element 3, in its pointing direction, the adjacent element is 1. Therefore, I can swap these two. Now after swapping, I get the new permutation as 3 next to 1 next to 2. Now this is the new permutation. So for the new permutation, again start with checking in the pointing direction given. For the first element 3, in its pointing direction there is no element present, therefore I can skip to 1. So in the pointing direction of 1 there is adjacent element 3. Adjacent element 3 is greater than 1, therefore 1 cannot be mobile element. Now move on to the next element 2. In the pointing direction of 2 there is an element 1. So the adjacent element 1 is less than 2, therefore the mobile element can be k is equals to 2. So now k is equals to 2. So this is the fourth step. Obviously you have to swap this. So since the mobile element is 2, you have to swap that mobile element with its adjacent element. Also, there is one condition we have discussed earlier in the algorithm, that is you have to reverse the direction of arrows for all the elements greater than k. So currently what is k? K is equals to 2. K is equals to 2. So you have to, what you have to do, reverse direction of arrows for all the elements greater than k. You have to check, is there any greater element than 2? Currently k is equals to 2 is the mobile element. What you have to do, you have to check if there is any greater element than 2 in the given new permutation. So in the permutations given, the new permutation given, there is a greater element than 2 which is nothing but 3. So you have to swap these two and change the direction of the element which is greater than k. So that is what the fifth step is. Reverse direction of arrows for all elements greater than k. So now k is 2. For k is equals to 2, there is a greater element that is equals to 3. Now change the direction of 3 and swap as usual 1 and 2. So change direction, don't get confused. So far in the here in this step k is equals to 3, there is no greater element than 3, therefore simply we have swapped and ended it. Now for the coming new permutation, I got the mobile element k is equals to 2. You have to check if there is any greater element than the current mobile element. So current mobile element is 2, but there is a greater element than current mobile element which is nothing but 3. You have to change the direction of 3, as well as you have to swap the mobile element with its adjacent element. So therefore I have swapped. So now this is the new permutation. Now check again repeat the steps from 2 to 6 like we have discussed. 2 to 6 you have to repeat until all the permutations are generated and there is no more mobile element present. So now yes, for this now check in its direction. For 3, in its direction is towards right. So for 3 there is an adjacent element to 2. In its pointing direction 2 is smaller than 3. Therefore I can write the mobile element as k is equals to 3 because 3 is greater than 2. Now, moving on to the next element 2. In its pointing direction, there is an adjacent element 3 which is greater than 2. Therefore, 2 doesn't become a mobile element. Now, moving on to next element 1. In the pointing direction of 1, there is an adjacent element 2 which is greater than this current element. Therefore, even 1 cannot be the mobile element. So, for this new permutation, what is the current mobile element? K is equals to 3. Now, check, is there any greater element than the mobile element? No. So, simply what you will be doing, then we will be swapping this mobile element with its adjacent element. What is the adjacent element for 3 in its direction? 2 is the mobile element that is adjacent to this current mobile element. Therefore 3 and 2 you have to swap. So 2 will be in that direction and 3 direction doesn't change. The direction only changes only when there is greater element than the mobile element. So current mobile element is 3, greater than 3 there is no other element, therefore the direction will be same. So 3 and next 1 I have swapped these two. Now the new permutation is 2 3 1. Let us check for this also. Again continue the same steps. In the pointing direction of 2 there is no other element, therefore I can skip to the next element. In the pointing direction of 3 there is an adjacent element 1 which is smaller than 3. Therefore now I can write k is equals to 3 as the mobile element because it is greater than this adjacent element in its pointing direction. Now moving on to next element 1. In the pointing direction of 1 you have the adjacent element as 3 which is greater than 1, therefore it cannot become the adjacent the mobile element. So now k is equals to 3 is the current mobile element. What you have to do, you have to swap this mobile element with its adjacent element in its pointing direction. So 3 and 1 are adjacent elements, 2 remains the same, 1 goes to this and this. Now again start with the permutation. So now go with the 2. In its pointing direction there is no element. So go to 1. In its pointing direction the adjacent element is 2 which is greater than 1. Therefore 1 cannot be the mobile element. Next moving on to 3. In its pointing direction there is no element. Therefore there are no more mobile elements left. Here we can end the generating of permutations. So what is the input I have taken? N is equals to 3. So n is equals to 3 is the input I have taken. So how many number of permutations can be generated? N factorial, that is 3 factorial, which is nothing but 3 into 2 into 1 which is equals to 6. So total 6 permutations I should have. So now you can check the first permutation, 2, second permutation, 3, 4, 5, 6. So I got total of 6 permutations. So this is how the Johnson-Trotter algorithm works. You have to initialize the first input with the pointing directions onto the left side and the elements arranged in ascending order. Now start identifying the mobile elements. Amongst it, you have to identify the largest mobile element, swap the positions with its adjacent element, then again generate the new permutation. Again go for checking the adjacent elements, identify the mobile element, then again swap. So if there is any case, in any case, if there is an element greater than the mobile element, you have to change the direction of that greatest element, which is greater than the mobile element. So here in third permutation, we got mobile element as 2, but there is an element which is greater than 2 which is greater than k, so which is 3. Therefore you have to change the direction of 3 and swap the mobile element with its adjacent element. So 3 direction is changed and 2 and 1 are swapped. So this is the new permutation. Again identify the mobile element, swap it with its adjacent element. I got new permutation. Again identify the mobile element, swap it with its adjacent element and go to the next new permutation. So these permutations will be generated until no more mobile elements are present. So there is no more mobile elements present in the last step, therefore we are ending it. So how many permutations we got? Total of 6 permutations. 1 2 3 4 5 6. For the input size n is equals to 3. So this is what the example we have discussed. Let us discuss one more example in the next video. Thank you.